Hello again, and welcome back to SNC1W. We are on Unit 2, Lesson 6, which is our final lesson of this unit. In this unit, we explored the relevance of chemistry to our daily lives, assessed the impacts of chemical processes and technology on society and on the environment, investigated the nature of matter by studying properties of elements and compounds, the structure of atoms, and the relationship between the atomic structure of elements and the organization of the periodic table. We also practiced creating Bohr-Rutherford diagrams. In our final lesson, we will be discussing ionic and covalent compounds. The learning goals for this lesson include explaining how ionic and covalent compounds are formed, and writing chemical formulas and chemical names of ionic and molecular compounds. Success criteria, or knowing that you have absorbed all of this lesson's knowledge, can be determined by whether you can complete the following tasks. So ask yourself, are you able to differentiate ionic and covalent compounds, write formulas of different ionic and covalent compounds, and write the chemical name of ionic and covalent compounds? The specific expectation targeted within this lesson includes C2.7. Before jumping into content, let's review a few key terms. A molecule is a group of two or more atoms that are joined together by a chemical bond. These bonds may be covalent, ionic, or metallic, depending on the types of atoms involved. A chemical formula is used to represent a molecule and tells us the type and number of atoms that are present. For example, CaCl2 is the chemical formula for calcium chloride, which is a molecule that contains one calcium atom and two chlorine atoms. A molecular element is a type of molecule that is made up of two atoms of the same element. This means that the chemical formula for a molecular element will be the same as the symbol for that element. Some common examples of molecular elements include Cl2 for chlorine gas, Br2 for bromine, F2 for fluorine, O2 for oxygen, N2 for nitrogen, I2 for iodine, and H2 for hydrogen gas. These molecules are important in chemistry because they are often used as reactants or products in chemical reactions, and they can also be used to study the properties and behavior of elements. So, why do elements form compounds? Well, atoms of most elements are inherently unstable when they exist in their pure, uncombined form. In order to achieve greater stability, these atoms need to acquire 8 electrons in their outermost shell, which is commonly referred to as the octet rule. By forming chemical compounds with other atoms, elements can share or transfer electrons, thus achieving this stable configuration of 8 valence electrons. Overall, the octet rule plays a crucial role in the formation and bonding of atoms, allowing for the creation of stable and diverse chemical compounds. Ionic compounds are a type of chemical compound that is formed by the combination of a metal and a nonmetal. They contain ions, which are charged particles that are formed due to the transfer of electrons between the two elements. When a metal and a nonmetal combine, the metal atom loses one or more electrons to become a positively charged cation, while the nonmetal atom gains one or more electrons to become a negatively charged anion. Ionic compounds are highly soluble in water, and their solutions have the ability to conduct electricity due to the presence of the ions in the solution. This property makes them useful in a variety of applications, including in the production of batteries and other electronic devices. So, to summarize, in ionic compounds, atoms give away electrons to get their 8 electrons. Metals give their electrons to nonmetals, and metals end up with a positive charge or a cation. Nonmetals end up with a negative charge, an anion, and because the ions are charged, they stick together in what is called a crystal lattice structure. An ionic bond is a type of chemical bond that occurs when one or more electrons are transferred from one atom to another. This results in the formation of positively charged ions, or cations, and negatively charged ions, or anions, that are attracted to each other due to their opposite charges. The electrostatic force of the attraction between these ions forms the bond. Ionic bonds typically occur between metals and nonmetals and are characterized by high melting and boiling points, as well as the formation of crystalline structures. Examples of ionic compounds include table salt and calcium carbonate. When naming a binary ionic compound, the naming convention is similar to covalent compounds, in that the nonmetal is named second. However, unlike covalent compounds, prefixes such as mono, di, tri, etc. are not used to indicate the number of atoms of each element. Instead, the name of the metal is stated first, followed by the nonmetal with its ending changed to IDE. For instance, the compound NaCl is named sodium chloride. Ionic compounds are formed by the transfer of electrons from one atom to another, resulting in the formation of ions with opposite charges. An example of an ionic compound is sodium chloride, or NaCl, commonly known as table salt. Sodium has one valence electron that it donates to chlorine, which has 7 valence electrons. This results in sodium becoming a positively charged ion, and chlorine becoming a negatively charged ion. The attractive force between the oppositely charged ions create a strong ionic bond, resulting in the formation of a crystal lattice structure for solid NaCl. Ionic compounds generally have high melting and boiling points, are soluble in polar solvents, and conduct electricity when dissolved in water or melting. When writing formulas for ionic compounds, the crisscross rule is a useful tool to determine the correct subscripts. First, you want to identify the charges of each element from the periodic table. For example, magnesium has a charge of positive 2, and bromide has a charge of negative 1. Then you want to write the symbols for each element in their corresponding charges as superscripts. In this case, the symbols are Mg and Br, and the charges are positive 2 and negative 1. Next, crisscross the charges to make subscripts. This means that the absolute value of the charge of one element becomes the subscript of the other element, and vice versa. So for the formula for magnesium bromide, we would do MgBr2. Remember to simplify the subscripts, if possible, by dividing the greatest common denominator. Naming ionic compounds involves identifying the cation and anion, and then combining them in a specific way. The cation is named first, followed by the anion, and the name of the anion is modified to end in IDE for binary compounds. For polyatomic compounds, the ion name is enclosed in brackets. Roman numerals are additionally used to indicate the charge of the cation. In the example of strontium chloride, the compound is named after the constituent ions strontium and chloride, with the strontium having a charge of positive 2 and the chloride ion having a charge of negative 1. For cobalt 2 chloride and platinum 2 arsenate, the Roman numeral in the name indicates the charge of the cation, which is positive 2, for both compounds. The compound is then named after the constituent ions, with the anion of platinum 2 arsenate having a charge of negative 3. It is important to include the ion name when referring to platinum 2 arsenate, as it is a polyatomic compound. Let's practice naming the following compounds: Please pause this slide until you have completed numbers 1 through 8. Okay, now let's see if you are correct. Please pause this slide and compare your answers to the ones found here. Next, please write the formula for the following binary ionic compounds, given the name. Please pause this slide until you have completed letters A through J. Okay, now let's check our answers. Please pause this slide and compare your answers to the ones found here. We are now going to shift our focus to molecular/covalent compounds. Molecular or covalent compounds are a type of chemical compound that is formed when two or more nonmetals combine. These compounds are unique because the atoms in the compound share electrons with each other rather than transferring them. This bond that is formed is known as a covalent bond. One important characteristic of molecular compounds is that they do not conduct electricity. This is because the shared electrons are tightly held between the atoms and are not free to move around. Additionally, atoms typically like to have 8 electrons in their outer ring, which is known as the octet rule. In molecular compounds, the atoms share electrons so that each atom ends up with 8 electrons in the outermost ring, satisfying the octet rule. Overall, molecular compounds play an important role in chemistry and are used in a variety of applications such as medicine, electronics, and agriculture. A covalent bond is a type of chemical bond where two nonmetal atoms, or a nonmetal and a metalloid atom, share electrons in order to achieve a stable electron configuration. This sharing of electrons creates a molecule that is held together by the attraction between the positively charged atomic nuclei and the negatively charged shared electrons. Covalent bonds are generally stronger than other types of bonds, such as ionic bonds, and are important in the formation of many molecules, including those found in living organisms. When naming molecular or covalent compounds, it is important to follow a few guidelines. Firstly, the name of the first element is written, followed by the second element's ending changed to IDE. Secondly, prefixes are used to indicate the number of each element present in the compound. However, mono is not used for the first element. Instead, di is used for 2, tri for 3, tetra for 4, and penta for 5. These prefixes allow for clear communication of the composition of the compound. Covalent compounds are formed when two or more nonmetal atoms share electrons. Hydrogen gas, noted as H2, is a common example of a covalent compound, as the two hydrogen atoms share a pair of electrons to form a stable molecule. In the case of oxygen, two oxygen atoms share 2 pairs of electrons, forming a stable molecule. Water, or H2O, on the other hand, is a covalent compound made up of 2 hydrogen atoms and 1 oxygen atom. In the water molecule, each hydrogen atom shares a pair of electrons with the oxygen atom to form a stable covalent bond. Covalent bonds have unique properties such as low melting and boiling points and can exist as solids, liquids, or gases at room temperature, depending on the strength of the bonds between the atoms. Let's review the formula and associated name of covalent compounds. The example on this slide that I will reference is for water, noted as H2O, a covalent compound made up of 2 hydrogen atoms and 1 oxygen atom. First, we need to identify our elements. We always start with the element furthest to the left or bottom of the periodic table. In this example, we have hydrogen. Following hydrogen, we have oxygen, which is the element furthest to the right or top of the periodic table. Next, we need to add our prefixes at the beginning of our element names. The prefix notes the number of atoms. For hydrogen, we have two atoms, so we use the prefix di. For oxygen, we have one, so we use mono. Lastly, we need to change oxygen to oxide, as this is the root of the element plus IDE. Let's practice naming covalent compounds. Please pause this slide as you write the names of each compound. We will compare your answers on the next slide. Now let's check our answers. Please pause the slide and compare the answers on the slide to your own. Make sure to double check those prefixes and the endings of IDE. The nomenclature of binary covalent compounds is a system used to name compounds made of two nonmetal elements. As discussed, the first element is named first, and the second element is named second using the suffix IDE. Greek prefixes are used to indicate the number of atoms of each element in the compound. Just as a reminder, the prefix mono is usually omitted for the first element. However, it is used for the second element if the subscript is greater than 1. Please review the examples on this slide. Ionic and covalent compounds, or bonds, are both types of chemical bonds that hold atoms together. Ionic bonds are formed between metals and nonmetals, while covalent bonds are formed between nonmetals. Ionic bonds involve the transfer of electrons from one atom to another, resulting in ions with opposite charges being attracted to each other. Covalent bonds involve the sharing of electrons between atoms, resulting in a stable molecule. Ionic compounds typically have higher melting and boiling points, while covalent compounds tend to have lower melting and boiling points. Additionally, ionic compounds tend to dissolve in water, while covalent compounds may not. And with that, we have officially completed Unit 2. Within this unit, we have reviewed the following big ideas. Atoms are the building blocks of matter. There is a relationship between the atomic structure of elements, their properties, and the organization of the periodic table. Elements and compounds have specific physical and chemical properties, which determine their uses, and the use of elements and compounds in consumer products and chemical technologies has both positive and negative impacts on society, the environment, and the economy. I hope that you have enjoyed this unit, and I look forward to joining you for Unit 3, where we will pivot to the world of physics.